Imagine a world buried beneath layers of sediment, fossilized bones, and forgotten epics. A world so ancient that even the dinosaurs had not yet drawn their first breath. A world where continents drifted slowly across the globe, where the atmosphere was thick with carbon dioxide, and where life was just beginning to crawl from the oceans onto land. This is the Silurian period, roughly 409 million years ago, a time when Earth was unrecognizable compared to today. But what if, beneath the weight of geological time, there lies a more unsettling question? Could an industrial civilization have existed on Earth long before humans? Not Neanderthals, not early hominids, but a species far older, perhaps even intelligent, that rose, flourished, and vanished without a trace in the fossil record? This is the heart of the Silurian hypothesis. Now, before you dismiss this as science fiction, let's be clear. The Silurian hypothesis isn't a claim that such a civilization existed. It's a thought experiment, a scientific provocation proposed by astrophysicist Adam Frank and climate scientist Gavin Schmidt in 2018. The idea wasn't to prove that intelligent dinosaurs or ancient amphibians built cities or launched satellites. Rather, it asked a deeper, more unsettling question. If an industrial civilization had existed millions of years ago, would we even know it was there? Think about what we leave behind. Cities, roads, plastic, radioactive isotopes from nuclear tests, massive changes in atmospheric chemistry from burning fossil fuels. These are the fingerprints of human civilization. But over millions of years, how much of that would survive? Would future geologists, digging through rock layers 50 million years from now, find clear evidence that Homo sapiens once ruled the planet? Or would we too vanish into the geological record like a whisper lost in a storm? The Silurian hypothesis forces us to confront the fragility of evidence. It challenges the assumption that intelligence and technology always leave behind unmistakable traces. And in doing so, it opens a door to one of the most profound questions in science. Are we the first technological species on Earth? Or could there have been others, long before us, whose rise and fall were erased by time? Let's begin by understanding what we mean by civilization. We typically define it by certain markers: agriculture, cities, written language, tools, energy use, and large-scale environmental impact. An industrial civilization specifically is one that harnesses energy, especially fossil fuels, to power machines, alter landscapes, and change the chemistry of the planet. That's us. Since the Industrial Revolution, humanity has burned through coal, oil, and gas at an unprecedented rate, releasing vast amounts of carbon dioxide into the atmosphere. We've altered the nitrogen cycle with synthetic fertilizers, filled the oceans with microplastics, and left behind radioactive isotopes from nuclear testing. These changes are so significant that some scientists argue we've entered a new geological epoch, the Anthropocene. Our impact is so deep and widespread that it will be visible in the rock record for millions of years. But here's the catch: most of these markers are relatively recent. The Anthropocene, as a concept, only spans a few centuries. So, how long would these signals actually last in the geological record? Take cities, for example. Skyscrapers, highways, and sprawling urban centers dominate our world. But concrete and steel don't last forever. In a few thousand years, most of our buildings will crumble. Without maintenance, steel rusts, concrete cracks, and asphalt disintegrates. Over tens of thousands of years, erosion, weathering, and tectonic activity would grind even the largest cities into dust. In a million years, the remnants of New York or Tokyo might be indistinguishable from natural rock formations. Plastics are more durable, but even they break down. While some microplastics may persist in sediments, their chemical signatures could be altered or diluted over time. And as for our most potent marker, radioactive isotopes like plutonium-239, these have half-lives of tens of thousands of years. After a few 100,000 years, their signal would fade into the background radiation of the Earth. So, if we assume that a similar industrial civilization arose 100 million years ago, would any of its technological debris survive? Probably not. The surface of the Earth is constantly being recycled. Plate tectonics subducts oceanic crust, mountains erode into sediment, and rivers carry material to the sea, where it's buried under layers of silt. Over millions of years, the surface is reshaped, reworked, and rewritten. The chances that any physical artifact from such a civilization would survive intact are vanishingly small. But what about indirect evidence? Could we detect changes in the atmosphere, oceans, or soil that might hint at a past industrial age? This is where the Silurian hypothesis gets really interesting. One of the clearest signs of human activity is the rapid increase in atmospheric carbon dioxide. Since the 1800s, COP's levels have risen from about 280 parts per million to over 420 ppm, a spike, unlike anything seen in the last 800,000 years of ice core data. This kind of abrupt change leaves a signature in the carbon isotope ratios found in sedimentary rocks. Specifically, when we burn fossil fuels, we release carbon that is depleted in carbon-13 relative to carbon-12, because ancient organic matter preferentially incorporates the lighter isotope. This creates a negative excursion in the USCC delta carbon-130 record. Now, here's the twist. Similar carbon isotope anomalies have appeared multiple times in Earth's history. One of the most famous is the Paleocene-Eocene thermal maximum, or PETM, about 56 million years ago. During this event, global temperature spiked by 5 to 8 degrees Celsius over a few thousand years, and there was a sharp negative shift in carbon isotopes, very much like what we're causing today. Scientists believe this was due to a massive release of methane from ocean sediments, possibly triggered by volcanic activity. But here's the question. If we didn't know the cause, could we rule out an industrial civilization as a possible explanation? The Silurian hypothesis doesn't suggest that the PETM was caused by ancient beings driving steam-powered cars. Instead, it asks whether we can be certain that such events weren't caused by a technological species. In other words, when we see a sudden climate shift in the geological record, do we automatically assume it was natural? Or should we at least consider the possibility, however remote, that it might have been driven by intelligence? This leads to a deeper philosophical issue, our tendency toward anthropocentrism. We assume that we are the first, and perhaps the only, intelligent species to evolve on Earth. But Earth has existed for 4.5 billion years. Complex life has been around for over 500 million. The window for intelligence to arise is vast. And while mammals didn't dominate until after the extinction of the dinosaurs 66 million years ago, other branches of the tree of life had their chance long before. Consider the Carboniferous period, around 300 million years ago. Vast swamp forests covered the continents, laying down the coal deposits we burn today. Insects grew to enormous sizes, dragonflies with wingspans of over 2 feet thanks to high oxygen levels. Amphibians thrived in the wetlands, and early reptiles began to crawl onto land. It was a lush, alien world. Could some form of complex social behavior or even proto-intelligence have emerged in such an environment? We don't know, but the fossil record from that time is sparse, especially for soft-bodied organisms or behaviors that don't fossilize. Now, fast forward to the Silurian itself, our namesake period. At this point in Earth's history, life was still largely aquatic. Jawless fish, early corals, and primitive arthropods dominated the seas. The first vascular plants were beginning to colonize the land, but there were no insects, no amphibians, no vertebrates on dry ground. The idea of a technological civilization in the Silurian seems absurd. No brains, no hands, no fire. But the hypothesis isn't really about the Silurian. It's named after a fictional race of reptilian humanoids from the British sci-fi series Doctor Who were said to have lived deep underground during Earth's ancient past. The name is a nod to the speculative nature of the idea, a playful jab at how science fiction often inspires scientific inquiry. So, what would it take for a species to develop an industrial civilization? First, intelligence. Second, the ability to manipulate the environment. Hands, tentacles, tools. Third, access to energy sources, particularly concentrated ones like coal or oil. And fourth, a reason to industrialize, perhaps population pressure, competition, or curiosity. Now, could such conditions have arisen in the distant past? Let's suppose, for argument's sake, that 100 million years ago, a species of highly intelligent cephalopods evolved in the shallow seas. Octopuses today are remarkably smart. They solve puzzles, use tools, and exhibit complex behaviors. What if, over millions of years, a lineage of octopuses developed social structures, language, and even primitive technology? Could they have harvested methane hydrates from the seafloor, built underwater structures, altered ocean chemistry? Even if they did, the evidence would be nearly impossible to detect now. Organic materials decay quickly in water, Underwater cities would be buried by sediment or destroyed by currents, and without fire, which is difficult to sustain underwater. Industrial development would face enormous hurdles, but perhaps they found other ways to generate energy: geothermal vents, bioelectric systems, or even early forms of nuclear fission using naturally occurring uranium deposits. This sounds far-fetched, and it is. But the point isn't to believe it. It's to recognize the limits of our knowledge. The fossil record is incredibly incomplete. We have fossils from less than 1% of all species that have ever lived. Soft tissues rarely preserve. Behaviors, languages, and cultures leave no direct trace. And over hundreds of millions of years, even the most dramatic events can be erased or misinterpreted. Take the Great Oxidation Event, 2.4 billion years ago. For most of Earth's early history, the atmosphere had almost no oxygen. Then, cyanobacteria evolved photosynthesis and began pumping oxygen into the air. This triggered a global catastrophe, the first mass extinction, because oxygen was toxic to most life at the time. But from our perspective, it was a necessary step toward complex life. Now, imagine if future scientists found evidence of a sudden oxygen spike in the rock record. Would they assume it was biological? Or could they imagine a technological cause, some ancient civilization terraforming the planet? Again, we're not suggesting that happened, but the Silurian hypothesis urges us to consider, when we look for signs of intelligence in the universe, are we too focused on finding things like radio signals or Dyson spheres? What if advanced civilizations leave behind subtle, transient signatures that are easily mistaken for natural phenomena? This has implications beyond Earth. As we search for extraterrestrial life, we often look for technosignatures, evidence of technology, such as artificial lights, atmospheric pollution, or megastructures. But if industrial civilizations typically last only a few centuries or millennia before collapsing or evolving beyond detectability, their signals might be brief and rare. And if they arise on planets with active geology, their traces could vanish in a few million years. In fact, the Silurian hypothesis suggests a disturbing possibility that industrial civilizations may be a common phase in the evolution of intelligent life, but one that is inherently unstable. The same intelligence that allows a species to harness energy and transform its environment may also lead to ecological collapse, resource depletion, or self-destruction. If that's true, then the silence of the cosmos, the so-called Fermi paradox, might not be because life is rare, but because civilizations don't last long enough to be detected. Back on Earth, this raises a haunting question. Are we just the latest in a series of failed experiments? Has Earth seen other species climb the ladder of complexity, only to fall? And if so, what lessons might their absence hold for us? Now, let's talk about what we could look for. If a prior industrial civilization existed, what traces might remain? Scientists have proposed several possibilities. One is unusual isotope ratios. For example, nuclear fission produces specific isotopes like plutonium-244 or curium-247, which are extremely rare in nature. If we found concentrated deposits of such elements in ancient rock layers, it might suggest artificial nuclear activity. Similarly, large-scale mining would concentrate certain metals, like copper, lead, or rare earth elements, in ways that differ from natural processes. Another clue could be synthetic materials. Plastics, for instance, are made from long-chain polymers that don't occur naturally. If microscopic fragments of such materials were found in sedimentary layers from tens of millions of years ago, it would be a red flag. But again, the chances of preservation are slim. A more promising avenue is the study of sediment layers themselves. Rapid changes in erosion rates, nutrient cycles, or biodiversity could indicate large-scale land use, agriculture, or deforestation. For example, the spread of agriculture by humans has increased soil erosion by orders of magnitude. If a similar spike occurred in the geological past, unconnected to known climate events, it might warrant a second look. There's also the possibility of technofossils, artificial objects that become embedded in rock. In the future, our landfills might fossilize into distinct layers rich in metals, glass, and ceramics. Could similar layers exist from the distant past? Some geologists have already identified strange, unexplained structures in ancient rocks, like the so-called Klerksdorp spheres from South Africa, which are small, grooved mineral balls dated to 3 billion years ago. While most scientists believe they formed naturally through mineral precipitation, their symmetry has fueled speculation. Could they be artificial? but they remind us that nature can produce objects that look designed. The real challenge is that we interpret the past through the lens of the present. When we see a sudden extinction, we assume it was a meteor impact or volcanic eruption. When we see a climate shift, we look for natural causes. We don't consider intelligence because, by definition, we believe we're the first. But that belief may be more cultural than scientific. Consider the Cretaceous-Paleogene extinction event, 66 million years ago. We're confident it was caused by a massive asteroid impact. The evidence is overwhelming. But what if there was more to the story? What if a civilization was already in decline due to environmental degradation, and the asteroid was just the final blow? We'd never know. The impact would erase both the civilization and its crimes against nature. This brings us to a more sobering realization. The lifespan of an industrial civilization may be inherently limited by its own success. The more a species alters its environment to meet its needs, the greater the risk of destabilizing the very systems it depends on. Climate change, biodiversity loss, ocean acidification. These aren't just modern problems. They could be universal symptoms of a civilization in overshoot. And if that's true, then the silence of the universe might not be empty. It might be full of echoes, faint, fading signals of civilizations that rose too fast and fell too hard. Earth, in this view, is not special. It's just another data point in a cosmic pattern. But let's return to the science. Is there any actual evidence for a pre-human industrial civilization? As of now, no. Every proposed anomaly has a natural explanation. The PETM was likely caused by volcanic activity in the North Atlantic. The carbon isotope shifts in the Ordovician or Devonian periods are linked to changes in ocean circulation or organic carbon burial. The fossil record shows no signs of tools, structures, or waste products that couldn't be explained by biology or geology. Yet, the absence of evidence is not evidence of absence. And that's the power of the Silurian Hypothesis. It doesn't require proof. It asks us to acknowledge that our understanding of Earth's history is incomplete and that our place in time is fleeting. In fact, if we project forward, the evidence of our own civilization may not last much longer than a geological blink. In 100 million years, the continents will have shifted again. The Himalayas will have eroded. The Atlantic may close. Our cities will be dust. Our plastics will be scattered molecules. Our radioactive waste will have decayed. And if intelligent life evolves again, perhaps from crows, dolphins, or AI, it may dig through the rocks and find a layer rich in carbon-12, a spike in extinction rates, and a brief anomaly in metal concentrations. They might call it the Anthropocene horizon, and they might wonder, who were these beings? Did they destroy themselves? Did they escape the planet? Or did they simply fade, like a dream upon waking? The Silurian Hypothesis, then, is not just about the past. It's a mirror held up to the present. It forces us to ask, what kind of legacy are we leaving? And if we vanish tomorrow, what would remain? It's also a call for better science. If we want to detect past civilizations on Earth or elsewhere, we need to refine our tools. We need to look not just for bones and footprints, but for chemical imbalances, sediment patterns, and isotopic fingerprints. We need to develop a forensic climatology that can distinguish between natural and artificial changes in Earth's systems. And perhaps most importantly, we need to expand our imagination. For too long, we've assumed that intelligence is a recent, rare, and uniquely human achievement. But the universe is old, planets are common, and evolution is a relentless tinkerer. If intelligence evolved once, why not twice? Why not more? The Silurian Hypothesis doesn't give us answers. It gives us questions. And in science, questions are more valuable than answers. They drive discovery. They challenge assumptions. They open new paths. So, the next time you walk through a forest or gaze at a cliff face layered with ancient stone, remember, you're standing on the grave of countless lost worlds. And somewhere, buried beneath millions of years of silence, there may be a whisper. A faint, almost imperceptible signal that we were not the first. Or perhaps we were. Perhaps Earth has waited 4.5 billion years for this moment, for a species to look up at the stars and wonder if anyone else has ever done the same. Either way, the silence speaks. And it is our duty, not just as scientists, but as thinkers, dreamers, and inheritors of time, to listen. Because in the end, the most profound discovery may not be finding evidence of a lost civilization. It may be realizing that the question itself changes everything. We are not just observers of the universe. We are part of its story. And that story may be longer, stranger, and more humbling than we ever imagined.